This video describes Tidewater Planetarium's ability to display lunar eclipses in a very realistic and representative way for all lunar eclipses over a 1,000-year period, back 500 years and forward 500 years. The eclipses are all displayed within a very narrow tolerance of the actual times that they will occur, and very representative of the angles and coverages of each eclipse. So what we've done here in this display, we're looking at the dome of the sky view for a location in the eastern United States. And we've set the date and time to September 27th, 2015, Eastern Daylight Time at about 7:30 in the evening. We can see that at that time of the day, on that date, the moon was just beginning to rise in the east and the sun just setting in the west. The sky was still quite bright. And that will always be the case in a lunar eclipse. The sun and the moon will always be on opposite sides of the earth, one rising as the other sets. So we're going to run this simulation. It's set to run at 380 times real time, so it's going to happen fast enough for us to see what's going on, and I'll try to describe it to you as it happens. But here we see the sun setting and the sky darkening. The moon is just a normal moon, and at about 8:30 or 20 hours and 30 minutes, the moon actually enters the outer shadow of the earth, which we can begin to see sliding down across the earth. I'm going to run it backwards for just a second because it was moving so fast. And here, you might not be able to see it in this video, but the moon is a little over half shaded in a very light shade, just as you would see if you were actually watching an eclipse. It's very difficult to perceive the outer shadow of the earth. But now the penumbra, the outer shadow, has completely engulfed the moon, and we're watching the umbra, the inner shadow, cover the moon. And as the moon goes dark, it actually in the sky looks like a deep red, and that's the way it's represented here. You may again not be able to see that in this video quite as clearly. Then the moon will stay within the umbra of the earth, the inner shadow, for quite some time before it begins to emerge. And when it does, you'll see light appear at one edge of the moon and gradually move across the face of the moon until it emerges entirely from the inner shadow. And then the process of the penumbra, revealing across the face of the moon and showing the moon's original bright white color, will proceed until the entire moon is once again visible at exactly the right time. This will be true of any lunar eclipse over the period of the 1,000 years that the model covers. And in addition to these things, you can display, if you wish, the Earth's shadow, which we now see emerging from behind the moon, really. At any time we can display where the Earth's shadow is relative to the moon, so you can watch near eclipses, near misses. Now, the moon and the sun are both displayed in Tidewater Planetarium about 3.5 times their actual diameter, for a couple of reasons. That's what the human eye expects in such bright objects in the sky, and they allow us to more clearly illustrate phases and other aspects of these objects' appearance in the sky than we could at actual size on any given display. But that means that their relative size is a bit bigger in the sky than they would really be. So here we can see the Earth's shadow at actual size, and in order to actually be an eclipse, the moon must pass into the inner reddish circle of the Earth's shadow. So this really represents closer to the actual size of the sun and the moon in the sky.